All right, so we are now done with all the review type questions that go over thermodynamics and stat mech. We're now going to begin reviewing, I guess, in a new sense, but now over the new material, the kinetics material. So problem number 6 asks us to basically analyze this mechanism, this abstract mechanism with no real molecules, just letters, but still a mechanism, for this overall reaction. And we're going to, in the end, we're going to identify the intermediates. So actually, that's the first question. Let's just do that. What doesn't appear in the overall reaction? Well, A doesn't appear, so those are intermediates. B doesn't appear, so that's an intermediate. Everything else does appear, right? That's an A, that's an A. A2, B2, and AB all are part of the overall reaction, so they are not intermediates. So A and B are the only intermediates. Then we got to write down all the rate equations. Then we're going to use the steady state approximation to finally get an overall rate equation for the production of AB. That's our final product in terms of quantities that don't involve intermediates. So this is the sort of standard mechanism analysis problem for this part of the class. So writing the rate equations we have. First of all, let's go through this a little carefully, since though we have done some of these problems before, it still doesn't hurt to be a little careful. So writing things down first for A2. We look, A2 appears there in the first equation, it appears in the next equation, and it appears in the last equation, so we're going to have 3 terms. The first term is going to be a first order term minus, right, because it's a reactant, K1 times A2 to the first power. The second term, it's a product with 2 reactants, and so it's going to be a second order rate law, plus K minus 1 times A squared. No 2 here in front, right? Because we're writing the rate for A2, which doesn't have a 2 in front of it, not for A, even though there's a 2 in front on the other side of the reaction. And then a third term coming from this reaction, which is going to be a minus K3 times B times A2. And I think that's it for that one. Now, for the intermediate A, that's going to appear, let's get rid of some of these extra arrows here. That appears in these first 2. It appears here and appears here. It appears in every single elementary step. So for the first step, it's going to be plus a 2 now, because its rate is going double to other things, times K1 times A2, right? A first order step because the reactants are first order. Minus, it's getting destroyed in this case, K minus 1, a 2 in front again because it's getting destroyed at twice the rate, times A squared because it's a second order step. Then minus K2, it's a reactant, times A times B2. And finally, for the last one, it's a product, so plus K3 times reactants are B and A2. Now, dB dt is equal to, okay, I'm running out of space here. B appears only there and there, so only in 2 of the steps. So it's going to be K2, it's a product there, times A times B2, those are the reactants, minus K3, it's a reactant, times B times A2. And let's see, I think the next one will be B2 dt. And B2 appears just one place, it looks like, yep. And so just one term, it's a reactant, so minus K2 times A times B2. And finally, out of space here, so let me shrink this up so I don't have to go down to a new page. Make myself some extra space. There we go. And so the last one is for AB. And and that is equal to, so AB appears in both this reaction and that reaction, and it's products in both cases, so K2 times A times B2 plus K3 times B times A2. All right, so that's all of our elementary rate equations. Let's make this a little bit neater here. Expand this out a little bit as much as I can. There we go. All right. And now we're going to apply the steady state approximation. That's actually part C that I didn't write down, I think. Yeah, I think so. So the steady state approximation says set the rate equations for all the intermediates to 0. And the intermediates are these two, A and B, so we're going to set both of these guys to 0. And then use those to solve for the intermediate concentrations like A here, or B here, and A here, and so on. I think I have a problem here. Well, we'll see. I think there might be a problem. Oh no, I think that's right. I think it's okay. All right. Solve for these intermediates. Oops. In order to eliminate them, right? Solve for them in terms of majority species like A2 and so on. So setting this guy to 0, we have 2K1 A2 minus 2K minus 1 times A squared minus K2 times A times B2 equals 0, or approximately equal to 0. This is an approximation after all. Oh, sorry, forgot the last term there. Plus K3 times B times A2, that's approximately equal to 0. And now using the B case, we have K2, and I'm going to write it over here, K2 times A times B2 minus K3 times B times A2 is also approximately equal to 0. And now you notice that these two, this business and this business, are the same, and in fact this business is equal to 0. That means all of that is equal to 0. So we can simplify our life by noticing that right off the get-go, and now we just have this much simpler equation to solve. And so this must be equal to 0 now. And so we have 2K1 times A2 equals 2K minus 1 times A squared. The 2's cancel out, and we get that the intermediate concentration is equal to the square root of K1 over K minus 1 times the A2 concentration to the 1/2 power. And that's a useful thing. Now we're going to plug that back into here in order to solve for this B concentration. So doing that, we have K2 times that A now gets replaced by that square root of K1 over K minus 1 times A2 to the 1/2 power times B2 minus K3 times B times A2 is approximately equal to 0. And now solving for B, we're going to have B is equal to, yes, K2 square root of K1 over K minus 1, A2 to the 1/2 power, B2, divided by K3 times A2. And therefore, B is equal to K2 over K3 square root of K1 over K minus 1 times B2 over A2 to the 1/2 power. All right, so now we've got our two expressions that express the intermediates in terms of only majority species, right? B2 and A2 in these two cases. Now we have to take our expression for the rate of change of our product and substitute in our new expressions wherever there's an intermediate in that product relationship. So let's do that. So there's our product relationship, or our product rate. I'm going to put in here for A, I'm going to put this guy in for A, so that gives me dAB dt is equal to K2 times all of that stuff, K1 over K minus 1 A2 to the 1/2 power B2. Then I'm going to substitute this guy in for B there, plus K3, let me see if I can give myself a little bit more space, K3 times K2 over K3, square root of K1 over K minus 1, B2 over A2 to the 1/2 power times A2, right? That A2 times divided by A2 to the 1/2 power just gives me A2 to the 1/2 power on top. This K3 cancels with that K3, and now look, the two ends, the two pieces of this are the same, and so we just get that's equal to 2. K2 square root of K1 over K minus 1 times A2 to the 1/2 power times B2, and that is our rate law. And let's see if the problem asks for anything else. I can't remember if it asks for anything else or not. It doesn't look like it does, so we're done.